How will AI and coding with AI evolve the role of software developers?
You know, the thing that's been true for those 4 decades of me programming is the job of the software engineer is constantly being reinvented. My daughter, who is in the 10th grade, texted me and she's like, "Dad, how do convolutional neural networks work?" But I was like in the car and on my mobile phone, I was like, all right, how am I going to answer this question quickly for this child? And I asked Deep Research the question. It took about 5 minutes of compute time to find 23 resources, including medical literature, and then it wrote code for the approach that it thought was best, and the code worked. You would have thought that we would have closed the gap more than we have between what the technology is capable of and what people are using it for. And I think if anything, especially over the past 6 months, the gap may have widened.
What is something that, with all these AI advancements, that you are particularly excited about? Something right now that you're really like, wow, in 10 years from now, this is going to have a fundamental change on how we operate as a society. Kevin, thank you so much for taking the time to chat with me today. Is that what you'd call it? I call it a maker studio, a shop. What would you call it?
Yeah, it's sort of an eclectic collection of things. We're sitting right now in a ceramic studio. Next door is a big wood shop, got a machine shop and a sewing studio. It's just brimming with possibility. Like you have an idea, you can go make a thing. And I think it's really important spending time with your hands, making things, makes you take the world of things that you consume less for granted. It's like a meditation, but object done, like after I'm finished.
I love that. I think that's great. But it's also interesting because threaded with being a builder, with pottery or construction, woodwork, code, or technology.
Yeah. There's a thread that runs through all of it, this impulse to make, and like the great makers that I know are all, curious about how things work, and like they're attracted to challenging problems and trying to figure out how things fit together to make something new and interesting. In that sense, no different coding than building a piece of furniture. And it's really funny, number of software engineers I knew who had wood shops in their garage, just crazy.
The first time I heard you speak on stage was about a year ago at Microsoft Build. I remember your talk so well. And the reason I remember it stood out to me from all the talks that day. Well, first of all, myself and I think the entire audience was glued to their seats. The way you were speaking about AI and future with advancements, it was kind of similar to how you're speaking about how you're building things with your hands today.
Yep.
It's easy to understand, digestible. You shared some very exciting announcements in a realistic but exciting way, which I'm really excited to sit down with you today and continue that conversation.
Thank you. Yeah.
One thing I'm very curious about is, how do you find balance, if you will, or how has your balance changed in both balancing exploration and practical applications when it comes to how quickly AI is advancing so many diverse fields?
I mean, it's really tough given how fast the technology is evolving. And so you really are having to do 2 things simultaneously. Like you are having to explore enough so that you understand where the frontier actually is. Because if you don't understand where the frontier is, it's very hard to set your ambition in an appropriate place. But at the same time, and this is the struggle I think that all great entrepreneurs and makers have, I'm biased towards finishing things. There's some aspect of making for making's sake that I enjoy, but like what I really like is doing the best that I can with the raw materials and the technology that's available, and then having something that I can give to someone else, and then I can see whether or not it's useful. And so at some point you do actually have to stop fooling around and start making something that you can start getting that feedback about whether or not this thing is going to be useful or not. And I think we're at an interesting spot right now, because you would think after several years of Gen AI just being at a breakneck pace, you would have thought that we would have closed the gap more than we have between what the technology is capable of and what people are using it for. And I think if anything, especially over the past 6 months, the gap may have widened. Like the technology is capable of so much more than we're using it for right now. It's really remarkable. And like I've got a bunch of little shocking anecdotes that share if folks are interested.
Yes, please share one. I would love to.
Well, so one of them is I was in the car with my wife a few weeks back coming home from dinner, and my daughter, who is in the 10th grade, texted me and she's like, "Dad, how do convolutional neural networks work?" And I was like, what? Why?
10th grade.
10th grade. Yeah, and so she's working at a cardiothoracic research lab at Stanford, and she's got this project that she's doing trying to build a blood oxygen saturation meter. So like the idea is like take an image of a retina and be able to reverse from the retina like what blood oxygen saturation levels are, and trying to see whether or not that can give you a more accurate reading than a finger blood pulse oximeter, which are not super accurate. And if you are in a surgery, like you need super accurate. She was asking about these CNNs, turns out, because one of the sub problems of designing such a thing is like you have to be able to do this process called segmentation of the image. So you need to take the pixels that are in that image of a retina and just get the blood vessel pixels out of it, which is one of those computer science problems that is easy to state. Like I just told you, you understand exactly what it is I intend. You could probably even sit down with a pencil and look at one of these images and you would be able to draw around the blood vessels. You could do the segmentation yourself, but that is super challenging code to write. And so she was just trying to figure out like what technique do I go use to write this code. And like I know how convolutional neural networks work, and I took image processing back in the dawn of time when I was a grad student. So like I knew a bunch of other image segmentation approaches, but I was like in the car and on my mobile phone, I was like, all right, how am I going to answer this question quickly for this child? And I asked Deep Research the question, and it was kind of mind-blowing. So I'm in the middle of this every day. Like I see what's going on. Like I've been paying as close attention to what's going on as is possible to pay for the past 6 years or so. And even I was like blown away. So this asked me a bunch of follow-up questions so that it could get more precise about what it was that I wanted. Like I did another turn of specifying what it was that I wanted. And it took about 5 minutes of compute time to find 23 resources, including medical literature, a bunch of citations for a bunch of different approaches, and then it wrote code for the approach that it thought was best, and the code worked.
Wow.
And, if I had been given that task when I was a computer science grad student, it would have taken me days, like maybe, like a week worth of, wall clock time to figure all of that out, to like go to the library, do all the research, read the papers, make sure I'm understanding what I read, like go write the code, test it. 5 minutes worth of compute time. I did it on my mobile phone. I texted a link to my daughter and she was like, whoa. If we hadn't had this technology and she hadn't had, like a computer science father, I think that would have been unreachable. So like, this is not like, like what's going to happen to software developers. It's like, oh my God, what an unlock. Like this made a thing that would have been completely impossible for someone who isn't a programmer possible. Like in the same way that it would be possible for you. So like it really is doing that thing that I've been hoping for a while with AI, which is getting past this point where getting something done computationally is incredibly complex because the abstractions that we have for doing them and the low-level details of the machines are super complex, to having a tool where you can just sort of say what you want and it can kind of understand it the way that an expert person would, and then go do what it is that you want. Because ultimately, it's like not the actual journey that's important. It's like, got a kid who needs to solve a problem.
Thank you for sharing that story. I love it. And it's so exciting. And a lot of what you hit on as well is, when you sent her that link, for example, it helped her walk through a potential solution or guidance to a solution, if you will. You mentioned it, shared the code as well.
Yep.
And then when you really think about, okay, now that she has that information at such a quicker rate, she is able to then finish the project or continue to advance even further in it because of AI.
Exactly.
Which really brings me to something else I'm curious about. What is something that, with all these AI advancements, that you are particularly excited about? And I know that that could be so many things, but something right now that you're really like, wow, in 10 years from now, this is going to have a fundamental change on how we operate as a society.
Yeah, like there are a whole bunch of things about the software engineering process that I think are going to fundamentally change that I'm excited about because I'm a software engineer. And like, we can talk about some of those later. But the things that I really am most excited about are these sort of scientific discovery and, healthcare applications of the technology, because I think the history of technology has been one where peak benefits accrue when the technology helps increase productivity somewhere where you have a real absence or shortfall of this thing that you need. And so if you look at one of the big problems that we have as a society right now is like, we just don't have enough high quality healthcare to go around for everyone. It is at the moment, and will stay like this until there is some kind of technological intervention. It's a zero-sum problem. And so all we're doing is like, we have a finite number of healthcare practitioners and a finite amount of our GDP that we're willing to spend on provisioning healthcare for people. And you can argue about like, it's more expensive than it ought to be in one place than the other, like this thing, but it really is like very zero sum right now. So the best you can do without some kind of technological intervention like AI is hope for things to just sort of move around, which means that the thing that you improve comes at the cost of sub-optimizing something else. And like, that's not me saying that like, there may be a better equilibrium than the one we've got right now, but like the even better thing than moving, that equilibrium around is really having something like AI come in and just create some abundance where it doesn't exist right now.
Exactly. And have you seen over time the adoption to different solutions using AI with, say, even the general public? Have you seen that get quicker, or people being more open to adopting to that?
Yeah, I think it's coming. And so, the problem with healthcare is, I almost picked the hardest possible thing because it's the place where we need to exercise the utmost caution in how it is we go deploy things, because, you really have people's health and well-being at the core of what you're doing. But that said, like, I think I've seen medical practitioners and companies that are developing therapeutics and medical technologies be more open to AI than I was expecting by like a substantial margin. And like, part of that is like, we've got a bunch of AI practitioners, computer scientists who just happen to be interested in medicine, so Peter Lee, who runs Microsoft Research and works in my team, member of the National Academy of Medicine, and like ran Microsoft's healthcare team. He's also like an artificial intelligence expert and like oversees a bunch of Microsoft's both healthcare and AI strategy. Eric Horvitz, who's Microsoft's chief scientist, like happens to be a computer science PhD and a medical doctor himself. And has been doing like really groundbreaking work, not just on the technology, but in trying to socialize what the technology is capable of to their fellow professionals in the field. Openness has been really wonderful, and it's good because like, there are things right now that the technology is already superhumanly good at. And and it's superhumanly good at things that we don't have enough of. So like, we should just be celebrating the fact that it's here, and we just need to work as hard as we possibly can to get it safely deployed.
Exactly. And speaking of Microsoft Research, one area that I've been reading a lot about is MatterGen. First of all, it's so cool.
Yeah.
And I'm probably oversimplifying it, but from my understanding, it's a Gen AI tool that can essentially help create new materials.
Yes.
What are some, do you have any examples of things with MatterGen that you were pretty blown away by?
Yeah, I think the thing that that the team showed, if I am, and like they've done a lot of things with it, so I'm hoping I'm correctly remembering the thing that they've talked about in public. But there are in material science a ton of things that we are constrained on, and like one of them is electrolytes for batteries. So at this point where if we really, really want to have the renewable energy revolution that we want to have, like you really have to solve battery storage density in a fundamentally different way than we have right now. And like, this is, just sort of prosaic things. Like if you sort of look at where the world's governments would like electric vehicle adoption to be versus where it is right now, like we're going to run into some like really gnarly problems with scarcity of materials like lithium, for instance. And so, it's really exciting to think about having tools like MatterGen that can help you explore what that space of possibilities are, hopefully helping you find better solutions for that energy storage density problem and hopefully solving it like super cheap. But like there are a bunch of other things as well. Like, there are new carbon capture catalysts that need to be invented. Like there are new, more efficient biofuels that need to be invented. There are like we still, after all of these years of looking, haven't really figured out how to make superconducting materials work at room temperature. Like there, are many interesting possibilities there that would like just absolutely transform the energy efficiency of the entire world if we could make the right discoveries. And like those are all just sort of inorganic material discoveries.
Yes.
So like, then you can sort of think about like all of the crazy stuff that people are doing in synthetic biology right now. And like all of that also, can be accelerated. So I don't know if you've looked into this much, but like one of the common practices right now is you can reprogram, things like bacteria and yeast to ferment and brew new materials. Yeah, and so, like we have an entire ecosystem right now in the world of like all of these materials around us are petrochemical based.
Okay, yes.
So, they're things that we make from, transformed carbon that we're pulling out of the ground. And like there are alternatives to all of these materials potentially that are organically synthesized. That can be renewable, like, they're not tied to that petrochemical
Yes.
base. I mean, like if you just sort of look at the sources of carbon emissions, like one of the places where we emit huge amounts of energy is in the manufacture of concrete. What if we had a construction material like concrete that had the same strength properties, but was, as cheaper, that didn't have quite the same carbon footprint. So I don't know, like, I'm just really super excited about all of that. And like we have material scientists who are doing really fantastic things right now, trying to discover these, but anything you can do to like equip them with tools to help them go faster, like just amazing.
This might not be a realistic question because no one can tell the future, but based on what you just shared, anyone who's watching this, I know they're going to get so excited because the possibilities they feel endless,
Yeah.
which, and so exciting to so many different solutions. My next question about that then would be, do you think a lot of these solutions that are being worked on are things that we might see in say, our lifetimes implemented?
I hope so.
That's a quick pace.
I think so. Mostly because a lot of these things that I just ticked off are kind of things that we already agree are urgent problems.
Yes.
And so, it's one thing to, for some harebrained engineer or scientist to come up with some brand new thing and no one even knows why it is you should care about it. But like we care about people being healthier. We care about having more sustainable energy infrastructure. Like I think we actually care about having more energy, period. So, like it's really interesting looking at the energy production and consumption patterns for the world. It kind of leveled off at the last quarter of the 20th century. We should want more energy consumption as long as it's sustainable, because like that means that we are using that energy for things that are likely very, very good. And like that energy usage intensity in the 20th century is like what drove all of these huge benefits that occurred in the 20th century. So when there are things that society clearly wants and needs, if a technology comes along that can help provide those things faster and cheaper, like I think we're not going to have a lot of problem adopting them.
100%. Kevin, you mentioned earlier on, we were talking a little bit about your story with your daughter when you input a prompt and it even gave you the code. I have a huge audience that is developers, and I come from a software developer background. I know you do as well. You're an engineer. I'm curious to get your take on, and I know this is a very popular topic, but I'm really curious to get your take on it, is how will AI and coding with AI evolve the role of software developers?
I think it's going to make software development a more important job, not a less one. I'm an old fart. Like I've been coding, I think now officially, I just turned 53 yesterday.
Happy belated.
Thank you. And I think I wrote my first program when I was 12 years old. So like I've been doing this for like 41 years now. I sound like somebody's grandfather. But the thing that's been true for those 4 decades of me programming is the job of the software engineer is constantly being reinvented because the pace of change in technology has just been relentless and fast. I don't think anything's different now than it's been. And it does mean that, the software engineering job, like if you just got into the profession like 5 years ago or 10 years ago, like it's going to be different in a few years than it was when you started. But it was going to be that anyway.
Yes.
And so like this is just a particular form that it's coming in. And so the thing that the most successful software developers will have is like curiosity and excitement about the new thing that is coming, and they will figure out how to get on top of it as quickly as humanly possible and how to leverage it to do really super amazing things. Like the things that it really is helping me, do, and like I'm not a production software developer anymore these days, is like just the amount of complexity required to be a competent software developer in 2025 is crazy high.
Yeah.
Like there's so much stuff that you have to be on top of. And I think it's going to be like a really amazing tool for software developers, helping them stay on top of all of this complexity. And it probably means, we're going to move up the level of abstraction in terms of what the job looks like. So, like when I started out, I was writing assembly language programs and loading programs off a cassette tape onto, computers, and my monitor was a 13-inch little color TV, and all of that was great and wonderful. I don't lament that I have more powerful tools now to do my job. And so I think that's what is going to change. Like your tools are going to become more powerful, which means not that you're going to have a less interesting job to do. You're going to be able to solve more complicated problems.
Solve more complicated problems. I couldn't agree more. Is there anything you can share with us or leave us with as we end this conversation that we should look forward to in particular that's coming up with Microsoft, or anything your teams are working on that you can share with us? I know.
Well, look, there's a ton of stuff coming. Like we have our big developer conference Build is in May. Like people should definitely get themselves signed up to attend in person or virtually this year, because we got a ton of really good stuff for developers that we're going to announce then. I think the general shape of what we're going to announce is like there's just continued progress that we're making on the power of the models that are coming out. So, just in terms of reasoning capability, but also like real clarity on what you need to complement those models with in order to help you write real agentic software. And so we've talked about a bunch of those things before, like really solving the memory problem so that you're not just transactional with your agents, like really figuring out how to make actions work so that you can have agents like actually do real work rather than just transforming tokens in a prompt and you're treating them like a question answering system, that you can sort of have them go perform real tasks and take effect on real world systems. So I'm just sort of super excited about the shape of that Copilot stack that's getting built out, that it's just year over year adding more and more capabilities that let people write more and more powerful software. And then, I think we're also going to show some more, cool scientific discovery stuff. We've had a whole bunch of papers in material science and computational fluid dynamics and computational chemistry and biochemistry. And so, just a bunch of stuff to share with people, that's going to be really exciting. I think Microsoft for 50 years has been really a platform company. The story of the company is that, we make things that help other people be successful. Yes. To, that their success is our success. And hopefully if we do our job right, the way the economics work out is like the vast majority of the value created and the benefits that accrue to people come to other folks who are building on top of what we're creating. I think we certainly had that with personal computing. Like we've had that with the internet, we've had that with the cloud, and I think we're going to continue to see that with AI for years and years and years to come.
Kevin, thank you so much for your time. I'm leaving this conversation similar to how I left your talk a year ago, which is pretty funny, which is really inspired and just really excited about the future and what's to come.
Good. I'm excited too. Thank you for coming.